Hello dear students, good evening everyone. This is the 20th lecture for class 12 physics and this is the last and very important lecture. In this lecture, we will derive a formula for electric field intensity due to dipole at any point, that is at an angle theta with the direction of dipole moment. Especially this is only one competitive examination point of view, but utilization of this one in axial condition as well as in equatorial condition very easy. When you just know about this formula, what is the formula concept, then you can find out the value of intensity in axial condition and equatorial condition directly by putting the value of theta. In axial means what, that is theta is equal to 0, in equatorial means that theta is equal to 90 degree. So in this derivation the most important concept is what, that is diagram concept. So let us see what is the concept of diagram. Electric field intensity at any point due to dipole which is inclined at an angle theta, which is inclined at an angle theta. This is the heading concept and diagram here very important. You have to understand what is the concept of diagram. Suppose this is dipole minus q charge and plus q charge, joining line here AB, and this is the center point O, and we have to find out any point here just taking K. So taking here a point K, the line joining K when extend in forward direction and gives the concept of axial line. And here if this line making an angle theta with the dipole moment axis, and another line that is making an angle 90 degree with this axial line. Suppose this one is starting line, that is A1, B1, and here A2, B2. So along this axial line that makes an angle theta with the direction of dipole moment, if intensity here E1 and just perpendicular to this, if intensity that is E2 and resultant of these two, if resultant intensity making an angle theta. Now theta here given another angle taking this one alpha, and by completing rectangle with the help of this rectangle, you can calculate the resultant intensity at point K due to this dipole AB. Always remember, whenever the diagram concept is clear, then you can derive the whole derivation up to last step, that is formula, very easy. So in this derivation, the diagram concept and another concept, that is the value of intensity in axial condition, E axial equal to what, 2p upon 4 pi epsilon naught r cube, and E equatorial, that is p upon 4 pi epsilon naught r cube. These two formula we will use directly here. because this is the special case, or we say that the standard case. In this case, the formula, whenever we obtain that formula, is very important formula. With the help of that formula, we can obtain this and this equation directly by putting theta is equal to either 0 degree, then we will obtain this one, and whenever theta is equal to 90 degree, then we will obtain this one. So for deriving this concept, we have to take the value of dipole moment effect. Dipole moment effect, it means the component of dipole moment, that is p cos theta here, and the p cos theta, that is along this direction, and p sin theta along this direction. So intensity along OK, that is E1, and the E1 value, that the intensity component will be cos component, because here the direction at an angle theta always means what? Cos component, and that angle here away from theta, that is 90 degree component, means what? Sin component. So in the terms of P, we will use what? That is P cos theta and P sin theta. But the intensity in axial condition, we will use this previous concept, 2P upon 4 pi epsilon naught RQ, and here P upon 4 pi epsilon naught RQ. But at the place of P, in axial we use what? P cos theta, and in equatorial we use P sin theta. So if E1 and E2 are the intensity along OK and OA2, then along OK and OA2, then resultant intensity at point K is the intensity represented by, suppose this one representing by K, this one L, and this one M, this one N, either OK or OL, and here this one K, E2 or KM, no problem. Then intensity at point K is the diagonal of rectangle KLNM, that is E is equal to E1 square plus E2 square. The value of E1, that is in axial case, the value of intensity what? That is cos component of P will use in this formula. So 2P cos theta upon 4 pi epsilon naught RQ plus, this is square term here, and here in equatorial condition what? That is P, so P sin theta upon 4 pi epsilon naught RQ whole square. Let's see, P upon 4 pi epsilon naught RQ, P upon 4 pi epsilon naught RQ common out, in square means taken out, P upon 4 pi epsilon naught RQ, then in square root, 2 to the 4, cos square theta and sin square theta will remain in square root. Then P upon 4 pi epsilon naught RQ, and this 4 cos square theta can be written in the form of 3 cos square theta plus cos square theta, 3 cos square theta plus and plus sin square theta, here this cos square theta plus sin square theta gives 1. So the formula will be that P upon 4 pi epsilon naught r cube square root 3 cos square theta plus 1. This is the required formula. In the direction here, formula very easy. In the direction concept, that is tan alpha is equal to, let's see, this perpendicular upon base, and perpendicular means what? The value of vertical component of the intensity, that is E2 upon E1 along this axial condition, that is the E1 value along equatorial condition means what? That is E2. So E2 value means that is P sin theta upon 4 का r cube, P sin theta upon 4 pi r cube, and whenever divided by 2 P cos theta upon 4 pi r cube, then 4 pi r cube in numerator, 4 pi r cube, this one 4 pi r cube, and denominator will be what? 2p cos theta, 2p cos theta, then 4 pi r cube cancel, pp cancel, so cos theta, sin theta upon cos theta 1 upon 2 also, so tan alpha is equal to 1 upon 2 tan theta. This is the formula for direction. Tan alpha is equal to 1 upon 2 tan theta. Then after this we will discuss about the special cases, how the equatorial conditions value and axial condition value will obtain. Then whenever all these terms are clear, then discussion about the special cases will be very easy. So we will put the value of theta at 0 degree and 90 degree, then everything will be clear. Let's see what are the concepts. Special case 1, when theta is equal to 0 degree, then E is equal to, it means this point lies anywhere on the axis of this dipole. It extend A towards left and B towards right, then will be the axis of dipole. Then the theta will be 0 degree, and then here cos 0 is 1, then 3 plus 1 4, so P upon 4 pi epsilon naught r cube 3 cos square 0 plus 1, that is equal 3 plus 1 4 means what? 2p upon 4 pi epsilon naught r cube. This is the formula, very simple. 2p upon 4 pi epsilon naught r cube. This is the formula for intensity in axial condition. I think this is the previous derivation, and this derivation is useful in deriving this formula concept, that is P upon 4 pi epsilon naught r cube 3 cos square theta plus 1. But with the help of this, you can also obtain this one by putting theta is equal to 0 degree. And when we put theta is equal to 0 in this concept angle, so tan alpha is equal to 1 upon 2 tan 0 degree. Tan 0 means what? 0. So everything will be 0. So tan 0 degree value 0. So tan alpha is equal to 0 is mean alpha is equal to 0 degree. It means resultant intensity of resultant here direction, resultant intensity at point particular that lies on axis of dipole, then the resultant intensity will be in the same direction where the dipole moment direction is given. But in equatorial we will check how the equatorial direction will be classified. This is the value for intensity, this is the value for angle. So put theta is equal to 90 degree, then E is equal to P upon 4 pi epsilon naught r cube 3 cos square 90 degree plus 1, and cos 90 we are knowing that 1, so 3 into 0 means 0 plus 1, that is 1 plus 0 1, so 1 square root 1, so P upon 4 pi epsilon naught r cube, this is the value of intensity in equatorial condition. So this formula is same as in previous case, we are deriving by direct diagram, and then when theta is equal to 90, then tan alpha is equal to what? 1 upon 2 tan 90, and tan 90 means infinity, so infinity upon 2 means what? Infinity, that is equal to tan 90, and tan 90 whenever that is equal to what? Tan alpha, then alpha is equal to 90 degree. It means the direction of intensity here resultant making an angle 90 degree with the direction of this one concept along this dipole, that is from A to B. Here if theta is equal to 90 degree, then the equatorial in this way, and the intensity direction will be just opposite. As we know from earlier derivation, the intensity direction in equatorial means what? Just opposite to the direction of dipole moment. So here also the direction of dipole moment here from negative to positive charge, but the intensity in this case will be what? Resultant whenever we just calculate the direction, then alpha will be what? 90 degree. So the alpha means just like at this point, this one will be what? 90 degree. Whenever this one will be 90 degree, then just from negative to positive E value, and this one just opposite to the direction of P. So each and every cases are very simple. When you just derive 1 or 2 times itself, then everything will be clear and easier for you. So thanks all for today.